Water solubility. Water can dissolve a lot of things. It also sticks together really well. Why? Mostly hydrogen bonding. What is hydrogen bonding, you ask? Well, I'm going to tell you. This is Luke's chemistry experience. I'm going to be telling you a little bit about water solubility, focusing on hydrogen bonding. It is going to be very interesting and we're going to have a fun time. But before I jump into what exactly hydrogen bonding is, I want to show you something called glucose, or sugar. Ah, bam! The sugar. Oh, I love sugar. This is sugar, or also known as glucose. It has 6 carbons, 12 hydrogens, and 6 oxygens. And I'm going to show you what happens when you put it in water. So after a little bit of mixing, the water becomes a completely clear solution. And it is a combination of the water and sugar molecules together. The reason it's happening is because of hydrogen bonding, and tastes like sweet water. So hydrogen bonding is happening in both of these glasses right now. This sugar water solution is very clear, and this straight up water looks almost entirely the same because of hydrogen bonding. In regular water, what causes the water molecules to stick together is an electronegative force in between them, holding them together. The reason is that certain atoms are more electronegative than other ones. And in the case of H2O, the oxygen molecules are a lot more electronegative than the hydrogen atoms. With the oxygen being really negative and then the 2 hydrogens being more positive, this causes an attractive force between the different water molecules, with creating little hydrogen bonds between each other, with O's being attracted to H's and H's being attracted to O's. Now, what's happening in the sugar water is that the glucose is replacing some of those bonds with itself. Glucose has carbons, hydrogens, and oxygens. And with those hydrogens and oxygens, they can go and replace some of those water molecules, filling those hydrogen bonds. So that's why it looks very clear, unless you had a lot of sugar in there. Most chemicals will often be water soluble when they have combinations of molecules that produce the positive and negative ends. And they are considered hydrogen bonds if they have an OH, NH, or FH that is causing that polar bond to happen. Another example is vinegar, also known as acetic acid. It has a formula of CH3COOH, which means it has that OH for hydrogen bonding. Like this vinegar here that has completely dissolved in the water that was present before, there are a lot of other things that are also water soluble, such as urea, which is found in your pee, which I'm not going to drink. Ooh. Another common example of something that's water soluble would be salt, or sodium chloride. But it actually doesn't dissolve in water due to hydrogen bonding. It's actually ionic bonding, which causes the salt to dissolve in the water. When salt dissolves in water, what happens is that the sodium breaks off and is surrounded by very electronegative oxygens. And then the chloride is surrounded by positively charged hydrogens. But I don't really need to show you how that works. Now, after everything I've just said, you might be thinking that everything's water soluble at this point, which, if that was true, then we'd have a problem. Thankfully, that's not true. A lot of things can't dissolve in water, and a classic example is fat, or cooking oil. Most oil or crude oil has carbons and hydrogens, which means it doesn't have a OH, NH, or FH that allows it to create those polar bonds in water, which means it won't dissolve. As you can see, even if I mix it, it doesn't want to bond with the water molecules in the slightest. With the oil unable to create those hydrogen bonds that it needs to mix, as you can see, it rests right on the very top with no intention of moving down, creating this nice silky oily layer on the top of your water molecules. Oh boy. Oh. Whew. That was my brief explanation on water solubility, a little bit of hydrogen bonding, and a tiny bit of ionic bonding. Thank you very much for watching and listening. My name is there, my student number is there. Please do not steal from me. Thank you very much for watching, and bye.